Let's start by taking a look at an example. The table below lists the average earnings of full-time workers as a function of the number of years of education beyond 8th grade. So if we look at this particular table, we see years beyond 8th grade and average earnings. So the years beyond 8th grade will be our independent variable, and the average earnings will be our dependent variable if we were to think of this in terms of a function. So as we look at this, the years beyond 8th grade, we have 0, which would be 8th grade, 4, which would mean finished high school, 6, which would be the first 2 years of college, and 8, which would be 4-year degree at college. Average earnings, $16,000, $24,000, $28,000, and $36,000. So what I'd first like to do is just plot the data. And when we plot the data, we create a scatter plot. So I created the scatter plot here, and you'll notice I put the 0, 4, 6, 8 on the horizontal axis, and I put the average earnings on the vertical axis. And then I just plotted the points in much the same way that we would plot points back in a basic algebra class. What we're going to do from here is find what is called the line of best fit, or the regression line. Doing this means we assume that there is a relationship between the independent and dependent variable. What we're going to be looking at at this point is linear regression, and so we're going to be looking for the line that runs through this data the best possible way. And we could actually start off by eyeballing such lines, just kind of making our best guess. And if I even did that with this particular example, I might draw a line that looked something like this, and I might draw it in a slightly different place, but I'd pick my best place to put the data. We're going to actually find how to compute that using our calculator as we go through the section.